Hello everyone. Today I'm going to solve the problem 1 of homework 5. Before going to the solution, let me walk you through the question. The question says a diatomic ideal gas have a rotational partition function approximately Q equal to 200, and we need to find the temperature where Q became so small that the quantum effects become important. There are three things. First is diatomic ideal gas, and there is something called quantum effects. So before going to the question, let's see what is quantum effects. So these quantum effects are something which are visible at atomic level or subatomic level. And when we are talking about atomic level, the things should be very small. And our Q, which is partition function, is nothing but a summation of all the energy state. So why you need a small q? It's just because of if your q is very high in order of 10 to the power 6, that means there are n number of energy states, and which is doesn't make the system in atomic level. So you need some q which should be very small so that your system would be in atomic level. And according to questions demand, they need to be less than 10, but there is nothing specific value. We assume it to be order of 10 or order of 10 square for quantum mechanics to be effective. Okay, so next let's go to the our question. So question is rotational partition function, and we know that the q rotation which I have written over here is equal to this. And the thing is, we need to consider one thing. The thing is, if T is greater than theta rotation or rotational temperature, then we can convert the equation. So you know that the theta rotation of these diatomic gases, always lies between 0 to 100 Kelvin. So you can blindly say that I can convert this equation to something like this: q rotation equal to T upon sigma theta rotation, where sigma for a diatomic gas is 2. Now there would be two conditions. One is gas could be linear, another gas could be non-linear. But for a diatomic gas, it's always in linear in shape. So we can write this formula. Otherwise, for a non-linear gas, the formula would be different. Okay, so now we have all the things. We know how the quantum effects are important. We have the formula for Q. Now you have to just calculate what is the value of temperature. So first thing, let's see how to get other values. So Q is given 200. I just wrote it here. Q is 200 at T equal to 300 Kelvin. So this should be 200. I'll just put the formula over here. 8 pi square Ik over sigma h square into 300, which is basically the temperature. There are a lot of values which are unknown. I really don't need to calculate. I need not to calculate this moment of inertia, sigma, all the stuffs. I can easily write this whole thing will be equal to 200 over 300, which is equal to 2 over 3. So I got this constant value. Next step is for quantum effects. For quantum effects, what do you want? We want q less than 10. This is questions depend. As I say, there is no specific value for quantum effects, and quantum effects always happens if your system is in atomic level. So okay, q is less than 10, then that means this whole constant into T should be less than 10. We can just input it in equation. 2 by 3 into T should be less than 10 or less than equal to 10, which implies as T less than equal to 30 over 2 or 15. And our T was in Kelvin, so the final temperature should be 15 Kelvin. As you can see, we need the temperature should be less than equal to 15 K, so that Q would be less than 10, and the whole system will behave as a quantum, or the system in the system we can see the quantum effects. Thank you. Let me know if you have any questions.